All right, let's do number one together. And then break this down. So the first thing you'll look at is what's the power term and the end behavior. So if I multiplied this together, what would be the largest term in terms of the exponent? And the answer is x to the cube. So if you went x squared times x and expanded it, there's your power term. That means it's going up to the right, down to the left, and we need to practice this notation. So as x approaches infinity, the function's going to infinity. As x goes to negative infinity, the function goes to negative infinity. So the right end goes up, the left end goes down. Next, I'm going to look at intercepts. So if I look at x squared by itself, and if I make that equal to 0 and solve it, I get the answer 0. 0 is an x-intercept. So if you plug in 0 for x and multiply it through, the answer is 0. The second factor, x subtract 2, the second answer is positive 2. So positive 2 take away 2 is 0. 0 times anything is 0. Those are the answers that give you the answer 0. Now look at the exponent for 0, where I got that answer. And see an even exponent? That means it's going to bounce at 0. And if you look here, what exponent don't you see that's here for the second factor? It's odd, which means it's going to cross over at 2. So we have end behavior, we have intercepts. Oh, we need the y-intercept. We did the multiplicity. To find the y-intercept, you plug in 0. So if I go 0 squared times 0 times negative 2, it won't take long to think the answer is 0. So there's your y-intercept. So we're going to graph that. You know you can press pause at any time. I'm going to change colors. So I just start with the x-intercepts, 0 and 2. The y-intercepts at 0, it's there already. And then I put down the end behavior. So I know the right end is going up and the left end is going down. And the last thing I want to find are the turning points. So I look at the x-intercepts and look for a number in the middle between them. So that number is 1. And so I'm going to plug 1 into the function and get an answer. So I'm going to go 1 squared, 1 times 1 take away 2, and then solve it. So if I solve that, I get the answer negative 1. I'm going to put that on my graph. And then I'm going to connect the points. I'd like you to write down and understand the relative maximum and min. So if I asked you for the relative max, that's that turning point, which is at 0, 0. If I asked you for the relative minimum point, that's this point here, that's at 1 and negative 1. So it has a maximum, a minimum. The end behavior, you draw it curved and smooth all the way, and you have it. All right, number 2. Again, you can use the graph paper at the back of your book. So let's break this down. Power term. So the power term of the first factor would be x squared. And of the second factor would just be x. So if I multiply that together, it's x cubed again, which means the right end goes up and the left end goes down. Oh, that goes to positive infinity. That goes to negative infinity. All right. X-intercepts and y-intercepts. So just the intercepts. So for the x-intercept, look at the first parentheses. What makes it 0? And you can see negative 2 makes it 0. If I look at the second factor, what makes it 0? Positive 2 makes it 0. Now look at the exponent. So the first one is an even exponent, which means it's going to bounce. And the second one, you don't see it, but it's an odd exponent, which means the second 0, the second x-intercept, it's going to cross. To find the y-intercept, we plug in 0 and solve it. So it's 0 plus 2 squared, and then 0 take away 2, and then solve that. So 0 plus 2 is 2, and 2 squared, so it's 4 times negative 2, so it's negative 8. All right, we're ready for the graph. I'm going to draw the graph in a way where I know I need to count down to -8. So 1, 2, 3, 4, 5, 6, 7, 8. So it's right there, -8. So we have -8. Our intercepts are at 2 and -2. So here's 2 and -2. And then the end behavior. So I know the right end goes up and the left end goes down. I need a value in between here to give me a turning point to estimate it. I could use other points and see what they are. So I'm going to do that. So +1, I want to know what the lowest point is out of 1 and -1. So if I plug in 1, and again go back to the function, and it's 1 plus 2 squared, and then 1 take away 2. That gives me the answer -9, because 1 plus 2 is 3 squared times -1. So that one's actually a little lower. So +1 actually gives me an answer. It's a little lower, so that's a better turning point. And I know -1, just by the shape of it and which way it's going to be actually a little bit higher than -8. So if I plugged in -1, -1 plus 2 squared, and -1 take away 2, I get 1 times -3. But you know, the more points you have, the more smooth and continuous the graph looks. I know it's going to bounce. So I know it's going to bounce at, see how it bounces at negative, just bounces and stays below. Well, at +2, it crosses over. The last thing I want you to put on the graph is to understand the relative maximums and minimums. So I'm just going to say, for the relative max, that's this point, right, where there's a tall turning point. That's at -2, 0. For the relative minimum, that's this lowest point, which is at 1 and -9. All right, number 2. I did number 2. Number 3. All right, are you ready to try this first? All right, well then let's do it together. So first the power term. So we have x times x times x. So if I put that together, it's a popular power term, positive x cubed. So I know it goes up to the right and down to the left. I can write that. So as x approaches infinity, the right, excuse me, the right end goes to infinity. As x goes to -infinity, the left end goes down. So I know the direction of the ends. If I ask for the intercepts, if I think of the x, and again, you should always press pause and see if you can do it first if you're ready to go. X by itself, the x-intercept 0, because if I plug in 0 for x, 0 times any number is 0. The next one is -2, and the next one is +4. I want you to look at the exponents that you don't see. Every one of the exponents on those factors is odd, which means that each x-intercept it's going to cross. No bouncing. All right, now we're ready to graph this. Oh, did I forget? I forgot the y-intercept, sorry. So if I plug in 0 for x, for the y-intercept, 0 times any number, the answer is 0. If 0 is an x-intercept, then 0 has to be the y-intercept too. All right, we're going to put these on our graph. 0, -2, and 4. I know the right end goes up. I know the left end goes down. And now we need to fill in more points to connect the graph together. So I'm going to start here at -1. And then I'm going to solve it. So where there's an x, I take out the x and put in -1. So this is negative 1 times 1 times negative 5. So a negative times a negative is positive 5. So that is a turning point. So now I know this part of the graph. And now I have a bunch of numbers in the middle here. I don't know which one will give me the lowest value out of 1, 2, or 3. So if I plug in 1, this one's going to give me a low value. It's 1 times 3 times negative 3. That's negative 9. So 1's going to give me the answer negative 9. Let's go 1, 2, 3, 4, 5, 6, 7. There's negative 9. I'm going to try f at 2 and see what answer that gives me. So take out the x and put in 2. So I see 2 times 4 is 8. Well, that one's going to be lower. Times negative 2. That gives me the answer negative 16. Oh, that's going to be off my graph. How can I handle it? I'm going to be okay. So 10, 11, 12, 13, 14, 15, 16. I'm going to say it's right there. It's going to be okay. So at 2, the answer is negative 16. I can't believe that 3 would be lower than that, but we're going to try. It might be. So it's 3 times 5, and it's negative. It's negative 15. So it's almost as low, but not quite. All right, we got this. Let me expand. It's all good. Making an omelet here. So all the way down. Turn all the way up. And then you have your graph. So last thing I want you to write down is what the turning points are. So if I asked you for the relative maximum, that's this point where it turns. So it's at negative 1 and 5. If I ask you for the minimum, it's the lowest point. That is, so not the ones that are the very lowest turning point. So that's at 2 and negative 16. All right, last one for your homework. This one I actually really want you to try before I do it. So can you make that commitment? Press pause and try it. Then press play to see whenever you need support or if you did it correctly. All right, here we go. So to find the power term, I take the first term times the first term, and then, oh, it's different. So it's negative x to the fourth. That means both ends are going down. So as x approaches infinity, the function goes to negative infinity, and the other side does the same thing. So both ends go down. Something different. Next, the intercepts. So again, I'm assuming you did it first, so I'm going to go a little faster. So the x-intercept. We have an x-intercept when we plug in 0 and when we plug in negative 2. Both exponents are odd. That means for both they're going to cross and not bounce. When I plug in 0, I'm going to get the same answer. These will match. 0x means 0y. Let's see how much I need here. All right, so the x-intercepts are at 0 and negative 2. The end behavior, both ends go down. So we have only one value to plug in between the intercepts. That's negative 1. So negative 1 cubed is negative 1, and a negative times a negative is positive. Negative 1 plus 2 is 1. So altogether that's positive 1. And that's it. So this is an example that only has a maximum. There's no relative minimum. There's only a high turning point, and that was at negative 1 and positive 1. That's an R. All right, I'm super proud of you that you did your homework. You tried your best. We're going to keep learning and working through this. Mr. G Math over and out. Till next time.